Greetings everyone. It is my great pleasure to be here to give a lecture, and in this chapter I will give a brief demonstration on the state-of-the-art of Fischer Tropsch synthesis and how it plays a role in the Nefertiti program. First, a brief introduction of myself. I got my bachelor's, master's, and PhD degree at the United States, and I'm currently a postdoc fellow at Professor Denmark's group at Peking University. My current research focus is on carbon dioxide and carbon monoxide conversion to alcohols. My primary research focus is on supported catalysts and its characterizations. So the primary reaction that we investigated in the Nefertiti program at Peking University is the famous Fischer Tropsch synthesis process. So the bigger picture is that with the depletion of crude oil and especially the growing demand for olefins, the Fischer Tropsch synthesis process is a promising alternative for the petroleum routes. The conversion of syngas that include carbon monoxide and hydrogen to produce high-quality fuels and key building block chemicals through the Fischer Tropsch conversion is of great significance for future energy sustainability. The investigation of Fischer Tropsch synthesis could be dated back to over a century, and the process was first developed by Franz Fischer and Hans Tropsch in Germany before World War II. Typically, we use supported iron, cobalt, ruthenium catalysts for producing hydrocarbons, and we also use rhodium catalysts for producing oxygenates. And here I'm showing the animation of molecular level of Fischer Tropsch synthesis, and the original copy is made by a famous researcher in the field, Professor Emil Hansen at Eindhoven University of Technology, who is also my previous collaborator. And typically, the conversion of carbon monoxide to hydrocarbons involves hydrogenation of carbon monoxide, the hydrogenolysis, which includes cleavage of hydrogen of the CO bound, and the formation of CC bound for chain propagation. It is a highly exothermic reaction with a standard reaction enthalpy of negative 165 kilojoule per mole. In Fischer Tropsch synthesis, the source of syngas can be coal, biomass, natural gas, also known as shear gas, as well as the photoreduction reaction of carbon dioxide. In traditional thermocatalytic Fischer Tropsch synthesis, we require very harsh reaction conditions that include using relatively high temperature and high pressure up to 5 megapascal. Also, the chain length distribution of products represent a broad and non-selective Anderson-Schultz fluoride, which was also known as ASF distributions. So you get a mixture of different products from carbon 1 to carbon 20 plus, but among them, olefins are most desired, and methane and carbon dioxide are considered as byproducts. The group has previously achieved progress in the photocatalytic pathway of Fischer Tropsch synthesis to achieve sustainability in the future. Compared with the reaction driven by thermal energy, we consider photo-driven reactions toward carbon monoxide and carbon dioxide utilization are sustainable routes by which to harvest the most abundant energy from our Earth and to produce desired fuels and chemicals. The photo-driven Fischer Tropsch synthesis process can dramatically change the product selectivity over the typical iron carbide catalyst. We achieve the olefin to paraffin ratio as high as over 10, under the carbon monoxide conversion higher than 49%. And the selectivity towards carbon dioxide was as low as 18%, ensuring a high carbon resource utilization efficiency. So in addition to olefins, ethanol has attracted considerable attention in the recent years because of its importance as a chemical raw material and renewable carbon resource. So to produce C2 oxygenates that include ethanol, we use rhodium-based catalyst, and the integrated photocatalytic Fischer Tropsch synthesis process is considered sustainable. We use sunlight as energy input and renewable water and carbon dioxide as feedstock, as well as producing alcohols as products. So we believe this process can give potential opportunities for sustainable in the future. And in the next section, I will provide detailed summary on how we utilize the photocatalytic Fischer Tropsch synthesis to produce ethanol. And we thank you for the listening, and please leave your comments and feedbacks. Thank you very much.